This video took me more time than I could have ever imagined. However, I have managed to create myself an off-grid solar installation, and I will share every step of this journey with you. First of all, off-grid means independent, without access to electricity from regular power grid. In my case, that was a must because I want to convert my 21 square meters container into a workshop. I have to mention that I have just finished the construction and I have nothing here. So, no electricity, but that's about to change. Because I have no access to electricity here, I have my chance to create one. But that has to be hard, right? And dangerous. Not to mention the costs. Well, yeah, and hell yeah. But not that hard, not that dangerous, and not that expensive as it turned out. I have started to break this task into steps that will lead me to my end goal, that is, reliable power for my container. First, I need to decide the power I need, money that I'm willing to spend, and space that I've got on my roof for the solar panels. Then, I need to design electrical circuits, and based on that, I need to pick right components for the installation. When I will have them, I have to install solar panels on the roof. And next, create and wire power storage. Yeah, I am making one myself. When everything will be ready, I will wire previously designed circuits in my container, and then I will install sockets and switches. Last but not least, I will hang an inverter on the wall, plug everything together, and hope that I won't catch on fire. As you can see, the volume of this topic begins to go a little bit out of hand. That's due to the crazy amount of knowledge and informations out there. This material could be a series itself, and that would be just too much for me. So, I came up with a compromise. I will try to compress the material into 2, maybe 3 separate episodes, and I will cover the most important things in the video, so you won't get overwhelmed and hopefully still enjoy the show. For those of you who are interested in details, I have crafted an ebook where I described how to make an off-grid solar installation. You will find there all the materials that I have created and gathered, like circuit schemes, calculations, tips on how to pick and purchase right components, and how to do the cheap, of course, explanation of every step described as easy as I could, and many more. If I got you interested, you can purchase my ebook for a couple of bucks. This would help me greatly grow this channel. So for those of you who have decided to support me, big thank you. All the informations are in the description box below. Also, I feel obliged to state the obvious. Don't attempt to recreate anything you see me doing here in this video, unless you have the right knowledge and skills. I will be dealing here with deadly voltages and high power that can lead to fire. With that being said, let's roll with the video. There were several options that I considered for a right place to install solar panels on. I could build some sort of carport or something on which solar panels could be mounted, or even make a solar panel fence. However, the most appealing place for me was the roof of my container. That's the most obvious place since the roof is already there. So I started calculating how many solar panels I can fit there. Since I know there is 21 square meters on the roof, I already assumed that any reasonable power won't come out of it. But to my surprise, I've managed to fit 10 panels, 420 watts each. That's whopping 4,200 watts of power. That would work, I think. Knowing what's my bottleneck power will be, I've started to search for the heart of my installation. Inverter. There are so many brands of these, starting from the most popular and expensive like Huawei or Victron, to some Chinese non-branded units. Don't get me wrong, no matter what you choose, you most likely will get Chinese product. That's because Chinese market for solar components exceeds 80%. Some sources even estimate Chinese share in market above 90%. That's huge. And it wasn't always the case. This information gave me a glimpse of a hypothetical scenario in which most of the brands with their equivalent models share the same components. Of course, I don't know that for sure. Oh my god, it's so hot inside of this. I don't know how do you wear them. Surely though, inverters differ in their functions, and of course, how much power they can handle. I need an off-grid inverter, one that does not require a power from power grid. That also might be a perfect solution to anyone who does not have one, like myself. There are inverters which provide such an option but does not require one. In this case, you can plug any 230 volts AC power source, I'm talking EU standard, like from the power grid, or fuel-powered generator. These inverters are called hybrid inverters. Those can be useful when energy from your solar panels is not enough for some reason, and your batteries are empty. Batteries. Without them, you won't be able to store any power. That means when your solar panels are generating power, you have electricity. Otherwise, you don't. And when there's not enough power, inverter might turn off till solars will generate just enough energy to turn him back on. This can become a rapid on-off cycle, especially near dawn or dusk. That's why batteries are so crucial in off-grid installations. Obviously, I also want one, but all battery-related subject will be covered in another video. For now though, I'll just say that I picked 15 kilowatts power storage which operates on 48 volts. Another very important feature for me will be Wi-Fi connection. I need to know what is happening with my installation in real time. I won't be here as often as I want, so information about current status of my installation is very important to me. Last but not least important thing is a voltage range that inverter operates on. I will talk a little bit about that later, but you can build your solar circuit in many different ways. Most low power installations operates in voltage range from 100 to even 1000 volts. Mine solar circuit will operate in range from 280 to 380 volts, something like that. There are also a couple other features that inverter might have, like 3-phase AC output, parallel mode, many MPPT ports, different communication protocols, safety features, and so on. Finally, I've made my mind and chose Growatt SPF 6000 ES. Growatt is one of popular Chinese brands and it has features that I care about. It can handle up to 6 kilowatts, it has 2 MPPT ports with voltage range from 120 to 450, it does have Wi-Fi and handles 48 volts power storage. Also, it is very affordable, but we will talk about prices when I finish the whole installation, so stay curious. Like I am very much right now. Tell me, how much do you think I have spent on whole installation? I mean inverter, panels, battery, fuses, wires, and so on. Write your guess in the comment section below. So here what we end up with. 4200 watts solar panel grid, 6 kilowatts inverter, and 15 kilowatts battery. Now before I rush and purchase anything, I have to plan and design my installation. There will be 3 circuits. First one will be for my solar panels, then there is a very important one for power storage. Last one will be for my container AC outlets, and I will start from this one. I will use separate electric fuse boxes for all 3 circuits. I wouldn't recommend using one large box for all 3 installations because there will be different electric parameters in each of our circuits. Main switch, power meter, this one is optional, surge protection device or SPD, residual current device or RCD, and 4 overcurrent circuit breakers. I just won't use that B20. Let's test if breakers are working correctly. Main switch just simply breaks the circuit if turned off. Checked. Power meter is a device which is neutral for the whole circuit. Current just passed through it. So I need to check only if the phase and neutral wire are connected from input to output. Checked. Surge protection device, or simply SPD, protects your circuit from overwhelming voltage spikes, like when the lightning strikes in the building or nearby, which may result in high voltage inducted in your circuit. This device breaks and transfers all the energy to the ground. So, check. No beep. That's good. If there would be closed circuit, that would mean that SPD is broken or already used. So, checked. Then we have our residual current device, or RCD. Main purpose of this breaker is to protect me from electric devices I will use under this installation. For example, I will use here my CNC machine. If, for some reason, the voltage would appear on my CNC exposed metal parts, due to, for example, isolation damage, and I will touch it, I won't be electrocuted, because this RCD will break the circuit before. Last but not least, we got 4 overcurrent circuit breakers. This simply breaks after current in circuit exceeds certain amount. In most cases, 16 amps are used in home installations. Because there are different voltage and wire diameter standards across countries, you need to be careful while picking right one for yourself. Mine AC installation is running on 230 volts, so 16 amps gives me around 3.5 kilowatts of power per circuit. If from one circuit I would want to drain even more power, this breaker will pop. First electric box done. Now we can move on to power storage fuse box. This one is specific because there will be only 2 components. First one is a DC miniature circuit breaker, or MCB for short. This is dedicated breaker for power storage units. This pretty complex device protects from overvoltage and mainly from overcurrent. Mine will break the circuit when current exceeds 125 amps. That's because I have 48 volts power storage. When it will be charged to maximum, it can even reach 57 volts. That means 48 times 125 gives me 6 kilowatts, which is max power that my inverter can handle. 57 times 125 gives me a little bit above 7 kilowatts, but that's not the problem. Main purpose of this breaker is to stop this tremendous current transfer that lithium iron phosphate cells that I will use can produce. Every single cell can handle up to 200 amps of continuous load, and in a moment of short circuit, it can produce whopping several thousand amps. In 48 volts power storage, I have got 16 of those. In the moment of short circuit, that's basically a welder. It will melt instantly everything. First isolation, then after reaching thousands of degrees, even thick copper wires. A kindly reminder though, auto-ignition can happen after reaching just 300 in Celsius. To answer unspoken question, yes, this is the main reason why solar installation gets on fire. So please, it's no joke. You need to be very careful with such high power batteries. You know, one time I was making a power storage for somebody. I was about to connect BMS, battery management system, to already assembled 48 volts battery. BMS has very little power consumption, so it has quite thin wire. I wanted to reach for that wire, but I already had a screwdriver in my hand. Carelessly, I touched battery minus with a screwdriver and a battery plus with a BMS wire, which is supposed to be on a plus by the way, but the other end of that wire shouldn't supposed to touch the screwdriver. I closed a circuit with a wire and my screwdriver. Happily for me, wire was much more thin than a screwdriver, and after connection, it just exploded immediately. If, God forbid, I would close a circuit with a screwdriver, then it would weld right away to the anode and the cathode of that battery. It would burn my hand badly, and the last thing I could do is just to run away to safety where I can watch fireworks from the distance. Let's get back to the topic. Second element I will use in my electric box will be simple cartridge fuse. This fuse is an equivalent of a wire that will melt exactly after reaching 125 amps in my case. It is just a single line of protection after MCB. It's redundant basically, since MCB does the same thing and more, but I want to be extra safe here. 2 of 3 done. Last electric box is dedicated for solar panel circuit. I will use here 2 components. DC circuit breaker for 500 volts and 16 amps. This is because my solar grid will operate on range from 280 to 380 volts and will produce maximum 14 amps. Second component is SPD for DC circuits. The principle of operation of this component is the same as in AC circuit we did before. Last electric box is done. If you want to dive a little bit deeper and understand what's going on in such installation, I have explained everything clearly in my ebook. If you are interested, everything you need to know is in the description box below. That was a lot of stuff to cover. Let's take a rest from it and make an OSB wall which will support whole installation. I have already choose a plan for my installation. It will be right near the entrance. First, I will take the measurements. Then I'm gonna cut an OSB board. And finally, screw it to the wall. Time has come. Grow-Out Inverter arrived and we can do the unboxing. What do we have here? a manual, Wi-Fi adapter, M4 sockets with a bunch of wire connectors and protective cap for battery socket, USB, Ethernet and communication bus cables. Now, the heart of the installation, grow-out inverter. Get the hell out of here, you dirty box! There you go. So what we got here? Here is a DC connection for power storage. This is AC input, AC output. That will be connection to the whole installation in my container. Two MPPT connectors. Those will be used, well, I will use only one because I will install only one string, 10 panels. Communication ports, ground. Here is BMS. I will have JK BMS for power storage. Hopefully everything will fit, because as you can see, this is quite large. Let's see if that will fit. Inverter is a little bit heavy, around 15 kilograms. So I decided to mount it in place where behind OSB board is a construction wood of my container. After finding the right spot, it's time to hang inverter on the wall. And I cannot feel my legs. Inverter is mounted. Now I need to think how to fit 3 electric boxes, power storage and wires around the inverter. I have marked all places with my pencil, and now we can move on to installing solar panels on the roof. I have researched a lot of stuff recently, and let me tell you, even mounting solar panels on the flat roof is not that easy. So here we go. Most of the cases solar panels are mounted on aluminum profiles. These profiles are in parallel to your roof slope and share the same angle. Most roofs are placed in some sort of an angle, for obvious reasons. Rain. In terms of solar energy production, that can be beneficial. Sunlight at noon in most of the places on Earth is still at some angle, so having, let's say, half of your roof at 30-degree angle can place your solar panels in close to 90-degree angle to the sunlight vector. Solar energy production will be at peak then, and this is of course sweet spot and your end goal. Another thing that you need to take into consideration is ecliptic of the Earth. You see, depends on the place you live, you will get more or less sunlight during the day. But we are more interested in kilowatts per day, and I was able to find such a map. Here you can see regions which generates the most. Me on the other hand, I'm going to ignore all that because I want to keep flat roof. At least for now. I am aware I will waste solid percentage of energy that way, but I'm willing to accept that. Anyway, Here are a bunch of screws, connectors and flat bars that I will use to secure solar panels to the roof. First, there is this big screw that bottom half goes into the wood, and top with a flat bar is used to mount aluminum rail. Then we got an aluminum connector which will be used to put two rails together, since I've got rails that are 1.1 meter long. And last element are clamps. These are used to secure solar panels to the rail. That being said, let's mount that crap on the roof. Guys, we are going to the roof. Alright, so much have been done already, but there is still a lot to do. In the next video, I will show you how to make a power storage from scratch. I have ordered batteries and BMS from China, and I'll show you how to put it all together. This way you can have a reliable power storage for a fraction of a price. If you enjoyed the show, please consider leaving a like and subscribe. You can write whatever comment you like for better video placement. And don't forget you can buy my ebook about off-grid solar installation. So, till the next video.